All right, so we're on the very last video, part 3 of section 2.7, partial fractions. So now we're going to look at repeated quadratic factors. So we did an example. I'm going to flip back over to grab that example if I can find it. Over here where we had a repeated linear factor where we had to do, let me show you down here actually. When we did this one, we had to have the x plus 1 as one denominator and the x plus 1 squared as a second denominator. So that's going to be important as well. But also, this is a quadratic factor, so we have to look at the pattern of the bx, oops, down here, bx plus c. That's going to come into play as well. Just want to say a heads up, very few of you are watching these videos, so if you are watching this video, I'm going to ask you to come to Zoom and tell me what color my pencil is that I'm using, and I will give you extra credit. So come to Zoom office hours and you can get your extra credit. And please don't tell your friends that are not watching the video, because that's really not fair to you. So I appreciate that you're watching this. So we're looking at repeated quadratic factors. Okay, again, we have to use the pattern with the quadratic factor. So that's going to be an ax plus b, and that's going to be over this factor to the first power. Then I also have to have another denominator as x plus 2 squared. Again, following the rules that we did when we had a repeated factor. We did it to the first power, then we did it to the second power. The bx plus c, that's coming from this example down here because the factor itself is quadratic. So I used a and I used b, so now I'm left with cx plus d. So we're going to multiply through by the common denominator, which will be this whole thing. Whoops. All right, so when we do that, these will cancel, and I'm left with 8x to the third plus 13x equals, this will cancel with one of these factors, and I'm left with ax plus b times x squared plus 2. And then this will cancel and this will cancel, leaving me plus cx plus d. There's really nothing for me to let x be that's going to be an obvious thing to get rid of anything. So this one's a little different. So I'm going to leave my left side alone, and I'm going to actually multiply these two binomials. So I'm going to be foiling them out. So ax times x squared is ax to the third. Then ax times 2 is 2ax. B times x squared is bx squared. And b times 2 is 2b. And then I still have this plus cx plus d. All right, so what I'm going to do now, this is kind of a cool thing, because I'm saying that this left side has to equal this whole right side. So let's look at looking at common terms. So I've got an x to the third term. So if I look over here, how many x to the third terms do I have? I just have one x to the third term and one x to the third term. So that tells me, since the coefficient in front of this x to the third term is 8, that has to be the same as the coefficient in front of that x to the third term. So that tells me right away that a is 8. Pretty easy. You could do that with the other ones as well. If you didn't want to start substituting things randomly, you could always multiply things out and do it the same way. Then I'm going to look at my x terms. So I've got the coefficient here, that's an x term. This is an x term. That's an x term. So that means the coefficient of this x term has to equal the coefficients of those x terms. So has to equal 2a plus c. Well, I know what a is. A is 8. So 13 equals 2 times 8 plus c. So 13 equals 16 plus c. So c equals -3. So I've taken care of this term, this term, this term. The next thing I'm going to look at is I have an x squared term here. Do I have an x squared term here? No. You could say there's a 0x squared term. So you could say that 0 is equal to b because you're comparing the coefficient in front of the x squared terms. So that's b's value. And the only thing left I'm left with is d. And how I'm going to compare that is I'm going to look at d. This is a term that is a constant. Is there a constant over here? No, there is no constant. So that means 0 equals d. So now I have all my values, and then I can put them in my equation up here. So I have ax, so that means 8x plus b, which is 0, so I'm not going to put anything, over x squared plus 2, plus cx plus d. Well, c is -3, so technically minus 3x, and d is 0, so plus 0 would be just -3x over x squared plus 2 squared. So this is equivalent to the original fraction. All right, on this next one, it says make sure you divide. The reason I have to divide is, remember when I talked about this numerator has the same degree as the denominator, so I have to actually divide this. So what I went ahead and did, and I have to use long division because I'm dividing by something that's not a linear term. So I have this little long division thing over here. So let's take a look. I'm taking x squared plus x minus 6 and dividing it into x squared minus 4x. So I do need a placeholder, a 0 placeholder for that. So I'm going to do first term divided by first term. So x squared divided by x squared is 1. Then I'm going to multiply 1 times all of that. And I'm going to subtract. So x squared minus x squared, that's gone. -4x minus x is -5x. And 0 minus 6 is -6. At that point, I have -5x divided by x squared. I can't divide that, so this whole thing is my remainder. So I'm left with 1, and I'm going to write it as plus -5x minus 6 over x squared plus x plus 6. So then I come back over here. I'm going to copy that down. Oops. And the next thing I would do is I would look to see, can I deconstruct or make this into two fractions? Well, I look, can I factor? And the only way to do this is if I can factor. So if it doesn't factor, we're not going to use the quadratic formula because that doesn't make sense, because we're trying to pull this apart into two factors, two things that add, they're not factors. But in order to do that, they has to factor. This does not factor. So at this point, that's all I can do. I'm just saying that this plus this equals this. I still have pulled it apart, but this does not pull apart further. So on my last example, again, this is an improper fraction because the numerator has a higher degree than the denominator, so I need to divide that. So I'm going to do that with long division over here. So that's what I did here. I set it up. I did the x cubed plus 2x squared minus x plus 1 divided by x squared plus 3x minus 4. So let's do that division first. So we do first term divided by first term. So x cubed divided by x squared is x. And then I'll multiply x times all of that. So x cubed plus 3x squared minus 4x. I'll subtract. So x cubed minus x cubed, that's canceled. 2x squared minus 3x squared is negative x squared. Negative x minus a negative 4x will become plus 4x, so that becomes plus 3x. And then I bring down the plus 1. Then I divide negative x by x squared, which would be negative 1. Then I take negative 1 divided by, negative 1 times all that, multiplied by all that. So negative x squared minus 3x plus 4. Again, I'm going to subtract negative x squared minus a negative x squared, cause that to be plus x squared, gone. 3x minus a negative 3x would be 6x. And 1 minus 4 is negative 3. So I'm left with x minus 1 plus 6x minus 3 over x squared plus 3x minus 4. So now I've got to take that and put it over here. So this right now is equal to x minus 1 plus 6x minus 3 over x squared plus 3x minus 4. All right, so now I need to focus on this. Can I deconstruct that? Can I make that into two fractions? So how I tell is I have to look to factor that denominator. So I'm going to just bring it over here. So I have 6x minus 3 over x squared plus 3x minus 4. So this does factor into x plus 4, x minus 1. So I'll do a over x plus 4. Again, it's just a because this is a linear factor, a power of 1, my x, plus b over x minus 1. Next thing I do is to get rid of the fractions, I multiply by the common denominator, which is that whole thing. So I've got x plus 4 times x minus 1, x plus 4 times x minus 1, x plus 4 times x minus 1. These cancel. So I'm left with 6x minus 3. X plus 4 cancels with x plus 4, so I'm left with a times x minus 1 plus x minus 1 times x minus 1, b times x plus 4. And then there are obvious values I can plug in for x to eliminate those a's and b's. So if I let x be 1, I can get rid of this and solve for b. So let's do that. X equals 1. So 6 times 1 is 6. Minus 3 is 3. Again, 1 minus 1 is 0. That's going to get rid of this. 1 plus 4 is 5. So 5 times b is 5b. So b is 3/5. Next, I'm going to let, thinking of this factor, I'm going to let x be negative 4. So negative 4 in this whole thing again. I'll do that over here. So 6 times negative 4 is negative 24. Minus 3 is negative 27. Negative 4 minus 1 is negative 5 times a. And again, the whole reason I'm plugging in negative 4 is negative 4 plus 4 is 0 times b is 0. So then a is 27/5. because both of those values have a 5 in the denominator, I'm going to factor out 1/5 for part of my answer. So you have to be careful. So over here, we still have this x minus 1 plus. So now I'm doing this part of it. I'm factoring out a 1/5. So then I'm left with 27 over x plus 4 plus b is 3, but I factored out the 3/5, but I factored out the 1/5, so 3 over x minus 1. Whoops. And that would be deconstructed. Woo! So that's the end of partial fractions. I know that was so much fun. So I hope to see you guys soon. Again, I do miss you, and good luck to all the seniors. Take care. Bye.